Now we have our second video for multiplying polynomials. This one will focus a little more on the FOIL method, but if you look down here at examples G and H, we expand further beyond just doing binomials times binomials. If we look at one like this, we have a binomial here and a trinomial here. So this technically isn't foiling anymore, but it's still kind of the idea of do the distribute piece from each of our terms in this piece to each of our terms in this piece. So we'll see what each of those looks like as we work through these examples. So example E here, we have two binomials. 2x plus 3 is one binomial, and x plus 5 is another binomial. So just like we saw earlier, we're going to do kind of that crab claw looking thing. 2x times each of these pieces, and 3 times each of these pieces. Remember, this piece here is first, this one here is outer, this one here is inner, this one here is last, F-O-I-L, first, outer, inner, last, or FOIL. So when we look at our first ones, 2x times x, that becomes 2x squared. When we look at our outer ones, 2x and positive 5, that becomes positive 10x, or plus 10x. As we work our way over here, 3 times x, we're doing our inside ones, becomes 3x. Because both of these terms are positive, it's a plus 3x. Positive 3 times positive 5 becomes positive 15. So right now, this binomial times this binomial gave us 4 different terms. The last thing we need to do here, though, is distribute and combine them into standard polynomial form. I guess we already did the distribute part, so we don't need to do that. We just need to combine into standard polynomial form. Looking at these terms, this 2x squared has the highest degree, an x squared. Nothing else is above a degree 2. And nothing else will combine with it, so our first piece is just 2x squared. Looking at some other pieces, we have a positive 10x and a positive 3x that can combine. Those two would become positive 13x. Lastly, we have this constant all on his own, this plus 15, so he stays at the very end there. It's at plus 15. So in the end, our solution is this, I'm going to do red around it, 2x squared plus 13x plus 15. That would be the answer, the solution to this binomial times this binomial. So, if we look at example F then, same idea, we need to FOIL these out. First, outer, inner, and last. So it's going to be very similar to the first one. The big difference here is we have a minus 4 right here, so we're thinking of it as being each of these terms times negative 4. So 5a times negative 4 becomes negative 20a. Oops. Oh, sorry. Shouldn't have done that one first. I was doing 5a times 3a becomes 15a squared. There we go. That was a little confusing for a second. 5a times 3a, 15a squared, because we're doing first. Please don't make that mistake. Now, 5a times negative 4 will become negative 20a. There we go. Because positive 5 times negative 4 is negative 20. Next one then, we do our inner. Positive 2 times positive 3a becomes positive 6a. Positive 2 times negative 4 becomes negative 8. Just like our last one, this first piece is our highest degree, and we can check that. This is a to the first, so degree 1, nothing, so degree 0, a to the 2, this is our highest degree, so that one needs to be on its own in the front as 15a squared. Negative 20a and positive 6a can combine. Negative 20 plus positive 6 is negative 14a. And negative 8 stays on its own. So we combine all of our like terms and simplify it down to negative 15a squared, or sorry, positive 15a squared minus 14a minus 8. That would be our answer, our solution to this binomial times this binomial. Let's go to these examples then. For g, we have this binomial times this trinomial. Okay, really the only thing that changes from before is we're not doing the crab claw thing. We're still distributing each piece, but you have to distribute it to 3 pieces this time, and then distribute this second term to 3 pieces. So in the end, we're going to end up with 6 different terms that you can see, and then we'll combine them down to whichever ones actually will combine. So we'll do 3x times 2x squared, and that'll become 6x cubed. 3x times 4x becomes 12x squared. 3x times, again, this is a negative 7 or a minus 7, becomes negative 21x. Now we move on to the second term here, negative 4 times positive 2x squared becomes negative 8x squared. Negative 4 times positive 4x becomes negative 16x. And negative 4 times negative 7 becomes positive 28. So just by doing all of our distribution, this new, I guess you'd call it a 6-nomial, polynomial of 6 different terms would be our answer, but we can combine things together and simplify it. And we'll see what will actually combine, what we can simplify down. This piece happens to be our highest degree, this 6x cubed. So that one is our very front piece, 6x cubed. We have 12x squared minus 8x squared. So those ones will combine. 12 is positive, negative 8. So 12 minus 8 becomes positive 4. So it's a positive 4x squared term. For x terms, x alone, we have negative 21x and negative 16x. When we combine negative with a negative, it's getting bigger or more negative. So we have negative 37x. And the last piece, we just have this constant plus 28 at the end. So in the end, our answer is a polynomial with 4 different terms, 6x cubed plus 4x squared minus 37x plus 28. Last example then. It's going to look just like the last one, only it's not a binomial times a trinomial, it's a trinomial times a trinomial. I'm going to get rid of this piece so we can draw some of these in. So when we do this trinomial times this trinomial, get rid of those as well. This n squared needs to go to each of these pieces. 3n squared, negative 7n, and positive 4. I'm going to do that first before I go on to anything else. N squared times 3n squared becomes 3n to the 4th power. N squared times negative 7n becomes negative 7n to the 3rd power, because remember this is like n to the 1st. N squared times positive 4 becomes positive 4n squared. Now it's from each of these paths, or each of these swoops. Next one I'm going to do is this 3n to each of these pieces. Okay, when I do that, 3n times 3n squared becomes 9n cubed. 3n times negative 7n becomes negative 21n squared. 3n times positive 4 becomes positive 12n. At this point then, I'm going to actually erase these red ones so that you can see where these blue boxes are coming from. I do this negative 2 to each of these. Negative 2 times 3n squared negative 2 times negative 7n, and negative 2 times positive 4. So again, all of those swoops, each one is going to be one of these boxes. Negative 2 times 3n squared becomes negative 6n squared. Negative 2 times negative 7n becomes positive 14n. Negative 2 times positive 4 becomes negative 8. So we've got a large polynomial here. We've got 9 different terms, but we know that we can combine some down. N to the fourth is our highest degree, our highest term, and none of these other ones would combine with it. It's the only n to the fourth that there is, so our first piece is 3n to the fourth. Next, we've got our n cubes. Here's an n cubed. Here's an n cubed. I think that's it for our n cubed. So negative 7n cubed plus 9n cubed would actually come out to a positive 2n cubed, or plus 2n cubed. The next one in blue, we've got n squared terms here, here, and here. Positive 4 minus 21 would become negative 17. Minus 6 more would become negative 23. So negative 23n squared. If it helps, if you need to, on your calculator, just take positive 4 minus 21 minus 6. You'll end up at negative 23. So it'll be negative 23n squareds. Let's look at our n pieces now. I'm going to go over the top. Positive 12n and positive 14n. Sorry, that one went right through it. Move it up. Those two would combine. When I combine those two pieces, the 12n and the 14n, those will add up to 26n. 12 plus 14 is 26. The last piece is just that constant, that negative 8, stays as negative 8 or minus 8. So in the end, we'll have this new polynomial of 5 different terms. 3n to the fourth plus 2n to the third minus 23n squared plus 26n minus 8. And that'll conclude our lesson on multiplying polynomials.